Greetings everybody and welcome back to the Specialist Maths 2023 Exam 2 solutions. We just finished multiple choice and I've decided to do extended response anyways, even though I have an exam to study for tomorrow. But I'm kind of in the mood for it, so why not? So yeah, let's just jump straight into it. So question 1, we have a scenic walking track. It's a piecewise thing with a cubic and some funny exponential function. We have turning points occurs at A, B's inflection, C is where they both meet. Show that A equals -1 and B equals 0. So we could it's probably enough just to make sure that those two parts of the function that pass through 1, 0. So maybe we can do it with limits. So limits as x approaches 1 from the negative side of f of x, that's equal to, what is it? It is -x plus a squared. So this is the limit as x approaches 1 from -1, 1 from the negative side of -x, and then x plus a. But this thing is squared, and applying the limits, we get -1, and then 1 plus a, and this is squared, and this limit, we want this to be equal to 0, which tells us that a has to be equal to -1. And we can do the limit on the other side, so limits as x approaches 1 from the positive side of f of x. This is equal to the limit as x approaches 1 from the positive side of, what's the exponential thing? It is e to the x minus 1. E to the x minus 1. And then we have plus x, is it? Minus x and then plus b. So minus x plus b. Applying the limits, we get 1 minus 1 plus b. And we want this to be equal to 0, so this tells us that b equals 0. So we have the two values there, which is quite nice. Okay, so part B, verify that the two curves meet smoothly at point C. So we already know that it's continuous at point C. So already continuous. So we just need to check that the derivatives match when x equals 1. So let's define the functions on the cas. That's probably a good thing to do. So I'm going to insert a new problem page, so doc 4.1, and I'm going to define f1 to be equal to f1 of x to be equal to the function. So that's going to be negative, was it -x and then x minus 1 and then squared? I think so. We should put a multiplication because x isn't a function. So multiplication, and I need to remove these brackets here. Okay. Is it -x minus 1 squared? Yeah. And then I'm going to define f2 to be equal to the exponential thing. So f2 of x to be equal to e to the x minus 1 minus x and then plus 0, I believe. Yeah, b is 0. Okay. And what we need to do is we need to evaluate the derivative. So it's already continuous. So we just take a look at the limit as x approaches 1 from the negative side of f prime of x. But that's just going to be the derivative, so shift to minus, of f1 of x. And that's negative. So the limit x approaches 1 from the negative side of -x minus 1 and then 3x minus 1. And that's going to be equal to 0. And then we check the limits on the other side. So x approaches 1 from the positive side of f prime of x. And that's the limit as x approaches 1 from the positive side. What's the derivative of the exponential thing? Actually, we don't need to use the cas for it. It's just going to be e to the x minus 1 minus 1. But what's that going to be? That's just going to be 0. So because the limits match, we have that it's a smooth point at C. Okay, part C, we have find the coordinates of point A, and also find the coordinates of point B. This is nice because A is the minimum, B is the inflection point. So we just need to run the analyze program on F1, it seems like. So I'm going to do methods, calculus, not differential calculus, just functions, analyzed. I'm going to do f1 of x, 0 to 1. And we get the local minimum, which is 1/3 to -427. So let's just write that down, I guess. -1/3 to 4 on 27. And then we have the inflection point, which is 2/3 to -2 on 27. Just 1 mark each, so we just need to say the answer. The return track from point D to O follows an elliptical path. We have x equals the thing with the cosine, y equals the thing with the sine. Find the Cartesian equation of the elliptical path. So just got to rearrange for for cosine and sine. So we have x minus 2 over 2 equals the cosine of t. And we have y over e minus 2 equals the sine of t. So just got to square both of these and add them together. That gives you 1. So we have, let's see, x minus 2 over 2, but squared. We could probably write it as x minus 2 squared over 4, and then plus y squared over e minus 2 squared, which I'm not going to expand out, and this is equal to 1. And I don't know if you want to cross multiply. That's probably as simple as it gets there. Sketch the elliptical path from D to O on the diagram on page 10. So what's the center of this ellipse? It's -2, 0. So the center is going to be 2, 0. And it's joining D to O. So I'm just going to guess it looks like that. And what's the direction? Well, it's going from, was it pi on 2 to pi? So we're just going to do that. That's the path there. I don't know, is that all? Yeah, that should be it. I don't know if we need to label endpoints. We probably do need to label endpoints. What's the endpoints? What's f2 of 2? f2 of 2 is e minus 2. So yeah, this is 2, e minus 2. And this is just 0, 0. Right. I don't know if you need to do much more than that, because it just says sketch. So yeah. Part F, write down a definite integral in terms of t that gives the length of the elliptical path. So we're just going to use the arc length formula, which I don't think it's too tricky to apply in this case, because you needed to find dx and dt, which is just -2 sine of t, and you needed to find dy and dt, which is e minus 2 cosine of t, and you need to square them, add them together, put it inside a square root, chuck it inside an integral from pi and 2 to pi, and you're done. So 4 sine of t, and then plus e minus 2 squared cosine squared of t in the square root dt. Find the length, so we can just evaluate this integral. Or if you want to, you can use if you have the programs, you can use the code length parameterized function, or you could just type in this integral, but let's just use this one. So what's x? X is -2 sine of t. Y is e minus 2 cosine of t, I think. Yeah. And then t is the parameter. We're going from pi on 2 to pi. 2.255. And this is 1 mark, so I'm just gonna write down the answer. 2.255. Yeah. Question 2 already. Was that all for question 1? Are you serious? Come on, VCAA. That was nothing. 10 marks. Alright. Did it in 8 minutes, or just under 9 minutes, so I guess we're looking good so far. Verified that w is a root of z to the 7 minus 1. Roots of unity, it seems like. So just got to plug it in and see if it works. So we have w to the 7 minus 1 equals cis of 2 pi on 7 raised to the 7 minus 1, and this is just cis of 7 times 2 pi on 7 minus 1, and that's cis of 2 pi minus 1 equals 1 minus 1 equals 0. That's the other roots in polar form. So how does roots of unity work? The solutions are cis, if I remember right, it's 2 pi divided by no, it's 2 pi k divided by 7, right? Where k is in elements of 0, 1 up to 6. So just 7 minus 1. I'm pretty sure that's the formula for it, if I remember my complex analysis. So yeah, I guess it's cis of, we have 2 pi on 7, that's the first root. Cis of 4 pi on 7. Actually, technically the first one is a cis of 0. And then we have cis of 6 pi on 7. A cis of, so this is k equals 3. K equals 4 would give us cis of 8 pi on 7. Cis of 5 would give us cis of 10 pi on 7. And then finally we have 12 pi on 7. So cis of 12 pi on 7. Okay, that should be it there. Alright, so yeah, 1, 2, 3, 4, 5, 6, 7, 7 roots. On the Argand diagram below, plot and label the points that represent all the roots. So 2 pi and 7 would be over here. Then we have 4 pi and 7, 6 pi and 7, 8 pi and 7, 10 pi and 7, and 12 pi and 7, and then 0. So I guess we just gotta write it down. This is really tedious stuff. This exam seems very easy so far. So 2 pi and 7. Maybe the last few questions are a bit more spicy than this. So cis of 4 pi and 7, cis of 6 pi and 7, cis of 8 pi and 7, cis of 10 pi and 7. You guys are probably getting bored already. Cis of 10 pi and 7, and then 12 pi and 7. Oops, 10 pi and 7, and then this is cis of 12 pi and 7. Okay, I think that's all for part C. Just plot and label. Okay. Part D. On the Argand diagram below, sketch the ray that originates at the real root of z7 minus 1, so that's just going to be 1 here, and passes through the point represented by 2 pi and 7, which is over here. So we have a ray that goes up like this, somewhat. Do we do closed or open endpoints? I can't remember. I'm pretty sure if you represent it by arg of something, then it's open, but I don't know. I'll just go open, because I don't remember drawing rays with closed endpoints. I don't know. Yeah, that should be it there. So this is, yeah, that's 2 pi and 7. Or cis of 2 pi and 7. Right, and that's 1. Okay. Find the equation of this ray in the form, yeah, if you write it as arg of something, then you have to have it open, where z is a complex number that is measured in radians in terms of pi. So I guess it's just arg of z minus 1 because it's coming out of 1. Arg of z minus 1 equals something. So that's the angle theta we want. How to get the angle of theta? Well, you know that's, let's see, you know that this angle over here, if you consider this triangle, that's an isosceles triangle, that's 2 pi and 7. Because it's isosceles, these two sides are the same, it's an isosceles triangle. Once these two angles are over here, so it's going to be pi minus 2 pi and 7 divided by 2. What's that going to be? Let's insert a new problem. So pi minus 2 pi on 7, and then I take this and divide it by 2. 5 pi and 14. So this thing is 5 pi and 14, and we want to find this angle over here. That's just going to be 9 pi and 14, I think. So pi minus this guy, 9 pi and 14. So yeah, it's just 9 pi and 14. I'm really hoping I'm doing these questions right, because it seems a bit too easy at the moment, and I don't know if I'm overlooking something that's supposed to make it harder. So I'll just go with that as the answer. Okay. E, verify that z to 7 can be expressed in the form... Why is VCAA just handing out free 1 markers? Like, come on, give us something interesting. Because this one you just expand, so you just literally FOIL out and you got z to the 7. So this is equal to z to the 7 plus z to the 6 plus z to the 5 plus z to the 4 plus z to the 3 plus z to the 2 plus z. And then you subtract off the same thing again. So minus z to the 6 minus z to the 5 minus z to the 4 minus z to the 3 minus z to the 2 minus z minus 1. Leaving you with z to the 7 minus 1, which is, yeah, what you want. Yeah. equals 0. Okay. Express cis of 2 pi plus 7 plus cis of 12 pi and 7 in the form a cos b pi. So what's cis of 2 pi and 7? It's over here. And 12 pi and 7 is sitting down over here. You want to add them together so you can think about vector addition if you want to. So it's going to end up, it's probably going to end up on the real line somewhere over here. So what's the question? It's express this in the form a cosine of b pi. So I can roughly see what you're supposed to do here. So this whole thing is equal to cosine of 2 pi and 7 plus I times the sine of 2 pi and 7. And you just got to realize that cis of 12 pi and 7, that's just the conjugate, complex conjugate. So this is plus cosine of 2 pi on 7 minus I sine of 2 pi on 7. If you want to see why it's the conjugate, I'm pretty sure 2 pi on 7 is, well, cis of 2 pi and 7 is the same as, sorry, cis of 12 pi and 7 is the same as cis of negative 2 pi and 7. Right? You could probably show that. I won't do it because I'm lazy. But yeah, these cancel, leaving you with 2 times the cosine, 2 pi and 7. Are we just doing like a tech free exam at this point? I don't know. Yeah, that should be it though. B pi, yeah. That should be fine. Okay, given that z equals cis of 2 pi and 7 satisfies this thing over here, use de Morbius theorem to show that this relation holds. Alright. So finally got a 2 marker. So let's see. We could probably... Using the pattern that satisfies this relation here, show that it's equal to negative a half. So de Morbius theorem, well, we know that cis of, let's say 6 pi and 7, is this equal to the cis of 2 pi and 7, but cubed, and cis of 4 pi and 7, that's a cis of 2 pi and 7, but this is squared. And maybe we can fit this into this equation here somehow. So maybe let's get all the other powers of, cis of 2 pi and 7. So what's cis of, actually, I'm going to write it on the right hand side. So what's cis of 2 pi and 7? But we raise it to the 4 instead. Well, that's just going to be equal to cis of 8 pi and 7. But can we write 8 pi and 7 in terms of 2 pi, 4 pi, or 6 pi and 7 is the question. Let's see. So where's 8 pi and 7? 8 pi and 7 is living over here. I don't think so. Maybe not. Maybe not. But it's the conjugates, isn't it? 8 pi and 7 is the conjugates of 6 pi and 7. And so are these other roots over here, are conjugates of 4 pi and 7 and the 2 pi and 7. I think I've done something like this before. In my algebra class at uni, when we were studying irreducible polynomials or something. So cis of 10 pi and 7 is actually the same thing as the cis of negative 8 pi and 7, which is, do I want to do that? So we have, let's get rid of this working out. I'm gonna start again because I think I know what I want to do here. So the idea is, I think we can rewrite this in quite a nice way actually, because if you take a look at this part over here, what you can do is you can write it as z to the 6 plus z to the 5 plus z to the 4, z to the 4 plus z to the cube plus z to the 2 plus z plus 1 equals 0. And then if you divide everything through by z to the 3, then you get z cubed plus z squared plus z plus 1, and then plus z to the negative 1 plus z to the negative 2 plus z to the negative 3 equals 0. So you get this nice kind of symmetry over here, which is nice when you're working with z to the 7, for instance. So negative 3 equals 0. So you know that z equals cis of 2 pi and 7 must satisfy this relation here. Okay. So what does that mean? It means that, let's take a look at z cubed, or z squared first of all. So z first of all is cis of 2 pi and 7, and then you have z squared is cis of 4 pi and 7, and then z cubed is a cis of 6 pi and 7. Right, so if you take a look at the sum over here, that's basically what we want. So z plus z squared plus z cubed. Now what's z to the negative 1? It's actually cis of, what was that conjugate point there? It was it 12 pi and 7, I think? Cis of 12 pi and 7, yeah. So this guy is cis of 12 pi and 7. But 12 pi and 7 is the negative of 12 pi and 7. That's the conjugate of cis of 2 pi on 7. And then you also have z to the negative 2, and that's a cis of 10 pi and 7. And then z to the negative 3, that's cis of, 8 pi and 7. But these guys over here, if you take a look at the cosine, if you expand everything out in terms of cosine and whatnot, I believe the imaginary parts should cancel each other out. Right, so if you take a look at the real parts of this expression over here, so if we bring this down over here, what we end up getting is cosine of 2 pi on 7, and then plus cosine of 4 pi on 7. Actually, it's 6 pi on 7 first because it's cubed. So 6 pi on 7 plus cosine of 4 pi on 7, and then plus the cosine of 2 pi on 7, and then we have a plus 1 over here, right? And then if you take a look at all these other guys, the real part of z to the negative 1 is equal to the real part of z, because it's just a conjugate there. So we have a plus another cosine of 6 pi on 7, and then plus cosine of 4 pi on 7. Oops. I want to undo. I undid too much. Oh dear. So 6 pi on 7 plus the cosine of 4 pi on 7, and then we have plus the cosine of 2 pi on 7, and this is equal to 0. So if you kind of collect everything together, you end up getting 2 times the cosine. There's a lot of writing over here. So 2 pi on 7 plus the cosine of 4 pi on 7 plus the cosine of 6 pi on 7. Oops. 6 pi on 7 equals 1. So this sum over here, which I'm not going to write down again because I've written it like 5 times already, is negative a half. This should have been a negative 1 over here because I bring the 1 over to the other side. That should be it there. I don't know if that's the intended solution, but that's just the trick I remember from my algebra class at uni, so I just used it. Anyways, question 3. We did not use the calculator once at all. Actually, we did use the calculator to check that our working out is correct and whatsoever. But let's take a look at question 3. Why is my whiteboard lagging? Okay, it's back to normal now. So the curve given by y squared equals x minus 1, where x is between 2 and 5, is rotated around the x-axis to form a solid of revolution. Write down a definite integral in terms of x for the volume of the solid of revolution. What's the volume of solid of revolution form? It's the integral from 2 to 5, and I always think of cylinder slices. So the width of the cylinder is going to be your dx. The formula for a circle, area of a circle, is pi times r squared, right? So it's going to be pi. The radius is just going to be the y, but then it's y squared, so it's going to be x minus 1. Find the volume. What we'll do is we'll insert a new problem page, and then we'll go to catalog, or go to calculus, and then we'll go to volume. Revolve volume. Okay, so it's going to be the square root of x minus 1, comma x, comma 2 to 5. 15 pi and 2. And you can do it the manual way as well. So integral from 2 to 5 of pi times, and then we have y squared, which is x minus 1, dx, same thing. So 15 pi on 2. Okay, express the curved surface area of the solid in the form, this thing over here, where a, big E, a big B are all positive integers. Alright. The closed surface area, express the closed surface area of the solid in this form. So integral from 2 to 5, the formula for surface area, you do something like 2 pi times the radius. So it's going to be 2 pi times the radius, which is y, which is just the square root of x minus 1. And then you multiply that by the square root of, it was 1 plus the derivative of y squared. So first of all, what's dy on dx? What's y, actually? How can I get rid of this? My whiteboard's not cooperating today. Oh dear. So y is just the square root of x minus 1. So dy on dx is going to be equal to 1 over 2 square root of x minus 1. My whiteboard is not working today. 1 over 2 square root of x minus 1. Right. And dy on dx, but this whole thing squared, is just going to be equal to 1 over 4 and then x minus 1. So we have 1 over 4x minus 1 square root, and then we have a dx. So 2 pi times the radius times the width over there. So if we simplify, this is the integral from 2 to 5 of the square root. We have x minus 1 minus 1/4 dx. So that's going to be, got a pi here as well. So that's going to be pi integral from 2 to 5, square root of x minus 5/4. Where a, b, they're all positive integers. So that means instead of 5 and 4 here, we got to rewrite this thing as, that's strange. So we have 5 and 4, right? Let me just check. So if you multiply this square root in, you're going to get, I'm forgetting a 2 out over here. So this is really 2 pi. 2 pi, maybe that's the trick. Right, so if you expand the numerator and denominator, you're going to get 4 over 4 here. You can pull the 4 in the denominator out, that becomes a 2, which cancels with this 2, and you're left with the square root of 4x minus 5. So 4x minus 5, and then dx, and that should be it there. There should be a 2. Right. Okay, hence or otherwise, find the curved surface area of the solid of revolution. Correct to 3 decimal places. VCAA, why are you giving us 3 questions? So, calculus, I'm not going to complain about the 3 questions, by the way. You'd expect something a little bit more interesting than just straight, compute this, compute that, and write the formula. But we wanted to go to revolve area. And then I'll type in the square root of x minus 1, comma x, comma x, comma 2 to 5. It's going to be that there. And it can check with the manual way, so integral from 2 to 5. And we have pi times the square root of 4x minus 5, was it? Yeah, 4x minus 5 dx. Let's hope we get the same answer. Oh dear, x minus 1. Maybe we did something wrong. Integral from 4x minus 5 times pi. That's strange. So we have 2 pi x minus 1, and then square root of 1, it's 1 plus, isn't it? It should be 1 plus. So that means we have a plus quarter here, and that means we get, so this should be negative 3 and 4. So instead of 5, we should have a 3. Okay, I almost lost like 2 marks there. So this should have been a -3 instead, and we get the same solution. There we go. All right. That's another tip, by the way. Sometimes it's useful to use the function that was given to you instead of, you know, what you got for working out, because you might get the, if you get the working out wrong, then your solution is going to be wrong, which I pretty much did. So correct the 3 decimal places, so I control enter. So this is 30.84, and then we have a 7. Total surface area of the solid consists of the curved surface area plus the 2 circular discs at each end. The efficiency ratio of a body is defined as its total surface area divided by the enclosed volume. Find the efficiency ratio of the solid revolution, correct in 2 decimal places. So total surface area consists of the curved surface. So total surface area equals, we have the 30.847, and then we have plus the 2 circular discs at each end. So what does that mean? It means that, yeah, you got to find the radius of the 2 discs at each end. So what's the radius? Well, we have y equals the square root of x minus 1. Oh dear. So at the start point, my whiteboard is really not cooperating with me today. So y equals square root of x minus 1. At x equals 2, we have, yeah, y equals just the square root of 1. So y equals 1. And at y equals 5, sorry, at x equals 5, we get y equals the square root of 4, so y equals 2. So we have 30 and then plus 30.847, and then we have pi times 1 squared, and then plus pi times, yeah, 2 squared, which is 4. So it's basically this guy, and then plus 5 pi. Right, so TSA equals, let's grab this value over here and just add 5 pi to it. What am I doing? Plus 5 pi. That's 46.555. So 46.555. Let's make sure I got everything right. So we have the total, yeah, the surface area, 30.847. We do, yeah, it should be 1, which is the radius of the start. And then, yeah, 2 is the radius of the other end. So yeah, it's 46.555. Efficiency ratio, so we need to take this and divide it by the enclosed volume. I think we found the volume. It was 15 pi on 2. So the efficiency ratio over here is just that number. So this thing divided by 15 pi on 2. So that's going to be 1.97, 1.98 if you round. So I'll go for 1.98. Okay. Question, oh, I got one more part. Then we've got differential equations, it looks like. So another solid revolution is formed by rotating this curve about the x-axis. For x, have we been doing this wrong the whole time? Surely this is the x-axis, right? Yeah, about the x-axis. Wait, then what's this question asking? It's saying another solid revolution is formed. Okay, so it's the same curve about the x-axis again, but between 2 and k. This solid has a volume of 24 pi. Find the efficiency ratio of the solid. Alright. So the solid has a volume of 24 pi. So let's try to find k first of all. It's 3 marks, so basically repeating everything we just did again. So we have, let's see. Let's do the volume. So we have calculus, we have revolve volume, and we have the square root of x minus 1, comma x, comma, and now we go from 2 to k. And then I'm going to solve this output equals, we have 24 pi with respect to k. K is not going to be negative, so we're going to have to find k equals 8. So the volume in terms of k is going to be equal to, yeah, I'll just write down some workings. So k minus 2 divided by 2 times pi. and we set this equal to 24 pi, and this tells us that k is equal to 8. All right, so we got the volume sorted, and now we just got to deal with the surface area. So surface area, and that's going to be equal to, the integral from, let's see, we have k equals, no, we're going to go from 2 all the way up to 8 of the exact same integral we had before. So that's the square root of 4x minus 3. Square root of 4x minus 3 dx. And then we're just going to calculate. So we do the integral from 2 up to 8 of square root of 4x minus 3 dx. That gives us that. Let's approximate 24.16. So we have 24.16, 649 at decimal places. So this should be more than the surface area we had before, which was, wait, why is that less? Surface area integral. Oh, I forgot the 2 pi. Oh no, just the pi. We need to add an extra pi there. Good thing I checked that. So we have, we need to multiply this by pi as well. So we need to grab this, and we actually need to multiply it by pi. Let's get rid of what these lines over here. So we have 75.9163. So 75.9163. Okay. So what's the total surface area? It's going to be that guy. And then plus pi times, what's the start point? It's the radius of the start point is just 1. Radius of the end point is just going to be 7. Right? Yeah, it's 7. Actually, root 7, but we square the radius. So this is just going to be, plus 8 pi. So let's add 8 pi to it. 101.049. 049. So the efficiency ratio is this going to be, we take the total surface area divided by the volume, it seems. So we just do this guy and divide it by the volume, which was 24 pi. 1.34. So nice and simple computations. You're just going to make sure you don't mess up your, your integrals and whatnot like I almost did there. 1.34. All right. That's 3 questions done. 2 more to go. Differential equations. Actually, how many marks have we answered? Just so I can keep track of time. So I've done 10 plus, are these all 10 markers? Oh dear. So this complex one was also a 10 marker. This was also a 10 marker, I think. They're all 10 markers. So it looks like, we've done 30 marks so far in 38 minutes, which isn't too bad. So question 4, another 10 marks, and I'm assuming question 5 is also 10 marks. Where's question 5? Question 5 is 11 marks. What? How many marks is in this exam? Oh, there's question 6 as well. Okay, that makes sense. So it's 60 marks. I was going to say, I was thinking that there was five questions for some reason. So we're actually only halfway through extended response. Alright, a fish farmer releases 200 fish into a pond that originally contains no fish. The fish population P grows according to this logistic model, where T is the time in years after the release of 200 fish. The above DE can be expressed as this integral thing. Find the values of A and B. Okay. I haven't touched logistic differential. I've done it like once. But I don't think I've studied it much. So how do you find the values of A and B? It can be expressed in this form. So I think we just need to do separation of variables or something like that. So that's going to be, if you rewrite this guy, it's going to be dt on dp is equal to 1 on p, 1 minus p on 1000. Right, and you want to integrate both sides. So it looks like we're just going to do partial fraction decomposition. So I'm going to go ahead and insert a new problem page. Expands. We have 1 divided by p times 1 minus p on 1000. So yeah, a is going to be equal to 1 and b is going to be equal to 1. Negative 1, because it's a negative over here. Okay, one form of the solution is this thing over here where d is a real constant. Find the value of d. Okay, so if we integrate both sides, what do we get? So we get something that looks like, if we perform the integral in the cas, so shift plus, we have just a normal integral of a, which is 1, divided by, actually we'll just copy it down from here. Copy that, paste it here. Can I copy, please? Copy. And then I'm going to paste it in here. And I'm going to integrate with respect to p, right? And that's going to give me that. And this is supposed to be equal to... Okay, so p is positive as well, because p is the population, I think. Yeah, population. So let's see. Is p greater than 1,000? P grows. Let's just assume p is positive, because I don't know actually. Does it say? So p is p on 1,000. Yeah, the fish population is growing, so I'll assume it's more than 1,000. So how do you find the value of d? Well, p, the solution for p, let's see. We have the log of p over p minus 1,000. We know this is equal to t. So what does this mean over here? We want to rearrange for p. So how do you rearrange for p? You can divide everything through by p. So log of 1 over, and then 1 minus 1,000 over p. This is equal to t. So exponentiating everything, you get 1 over 1 minus 1,000 divided by p equals e to the t. And rearranging once more, if you take the reciprocal of everything, you get 1 minus 1,000 over p is equal to e to the negative t, or 1 over e to the t. And let's keep rearranging. So 1 minus 1 over e to the minus t, or e to the minus t is equal to 1,000 divided by p. So finally, p is just equal to 1,000 over 1 minus e to the minus t. That should be it there, I think. So d is 1. Or d is negative 1 actually, because it's 1 minus e to the negative t. Alright, the farmer releases a batch of n fish into a second pond, which originally contains no fish. The population Q of fish in ponds 2 can be modeled by this DE, or by this function where t is the time in years after the n fish are released. Find the value of n. N fish into, okay, so n's the number of fish. So this originally contains no fish, so he wants Q of 0 to be equal to 0. Okay, there's no n in here, is the problem. Modeled by Q, this n fish are released. What? Which originally contains no fish. The population Q of fish in ponds 2. Oh, n's the, it can initially contains no fish, right? Wait, so this has to be equal to n. Yeah, because the population right after he releases it should be n. So yeah, Q of 0 equals n. So yeah, I'm just going to plug 0 into here and see what you get. So it's just going to be equal to, so Q of 0 is just going to be 1,000 divided by 1 plus 9. And that's equal to, what's 1,000 divided by 10? It's 100. Find the value of Q when t equals 6. Give your answer correct to the nearest integer. Define P of, or Q of T equals 1000 divided by 1 plus 9 e to the negative 1.1 times t. There's going to be a lot of 50s this year. So many 50s, because there's a lot of people that are going to get full marks on this, I think. Okay, so we just got to evaluate Q of 6. 988. Should be it. T equals 6. Yeah. Alright, parts E. Given that dq dt equals this thing, express d squared q on dt squared in terms of q. So we can product rule, probably. So I'm just, instead of writing dq and dt, I'm just going to write q prime. So q double prime is equal to, so we have 11 on 10, which we can factor out. And let's just perform the product rule, why not? So we have q prime, and then 1 minus q on 1000. And then plus, we have q. And differentiating the second part, you're going to get negative 1 on 1000, and then q prime. Okay, but this is equal to 11 on 10. Q prime, we know what that is. Q prime is this 11 on 10. Q, 1 minus q on 1000. And then we have, so this part over here, that's q prime. Then we also have another one of these factors, so this is squared, and then plus q minus 1 on 1000. Q prime, once again, is 11 on 10 times q, 1 minus q on 1000. Close bracket, close bracket, close brackets. Can we simplify this? Probably. So this is equal to 121 over 100 times the q times 1 on q on 1000 squared, and then plus, or actually negative now. So negative, we have 11 over 10,000, and then we have a q squared, 1 minus q on 1000. All right, should be it. Actually, we need to multiply in by an extra 11 on 10. Right, so this should be 100,000 and 121 instead. And that should be right. So 121. Hint or otherwise, find the sample size of the fish population in pond 2 and the value of t when the rate of the growth of the population is a maximum. Give your answers, or give your answer for t correct to the nearest year. So this is just a quadratic in Q pretty much. Again, we could probably simplify this further if we, expand things out and collect terms and whatsoever, but I really can't be stopped doing that. I'm already tired, so let's just brute force through this. So I'm going to define, actually let's just solve when the double derivative is equal to 0. So solve, let's see. We have 121 divided by 100, and then times q. Let's use a new variable. Let's use y instead. So we have y times 1 minus y on 100. 1000, is it? Yeah, 1000. But this is squared, and then we have minus 121 over 100,000, and then we have y squared. And then 1 minus y on 1000. We solve this equal to 0 for y. And we get y equals 500 and thousands. What was the initial population? It was 100. Let's see. So what does Q look like? I want to see what Q looks like. So I'm going to insert a new graphs page, and I'm going to graph Q of X. So it looks like that. But I want to, let's turn this into 1,000. Okay. So we have some kinds of growth here, looks like. So we kind of want to be over here. It looks like when Q is equal to, yeah, 500 roughly. So that's going to give you the maximum growth. I don't know why are we getting y equals 0 or 1000? Oh, because that's the that's like the asymptotes, right? That's the asymptotes, and we can't reach those asymptotes. So let's see. We know that Q equals 500. So we just got to solve for that. So solve Q of t equals 500 with respect to t, 1.997. Nearest year, so t equals 2. Right? So therefore, t equals 2. Find the size of the fish population in ponds 2 and the value of t. Yep, that's it there. 500 and t equals 2. T is in years, right? I think so. Is t in years? Value of t, what did it say before? Yeah, t is a time in years. All right. So it looks like that's that part. And then part F finally is to sketch Q, I think. Label any axis intercepts and any asymptotes with their equations. So we're going to have an asymptote at 1000 up over here. I'm not going to bother using a ruler. And let's see. Label axis intercepts and any asymptotes with their equations. We know that it starts at 100. So 100 is down here. And we're going to get an inflection at 2,500, so roughly over here. And it's going to go off like that. So yeah, the logistic model is going to look something like that there. Yeah, and this is, we have an asymptote at 0 as well. So this is y equals 0 and y equals 1000. And the axial intercept is 0, 100. Because that's the initial population. Let's just make sure. Is it the initial population? Yeah, it's 100. Okay. The farmer wishes to take 5.5% of the fish from pond 2 each year. The modified logistic differential equation that would model the fish population Q in pond 2 after t years is, in this situation, is this thing. Find the maximum number of fish that could be supported in pond 2 in this situation. Let's see. I think we can just use DE solve. I forgot how to use DE solve though. DE solve. DE solve. You put in, yeah, the variable, dependent variable. Okay. So you put in the equation and then you put in T and then you put in Q, it seems like. Differential equation solver. So let's see. What's the equation? It's 11 on 10 and then times Q and then times 1 minus, actually it should be Q of t, times, and then we have 1 minus Q of t, divided by 1000, and then minus 0.00, well actually 0.55, and then times Q of t. Independent variable is t, dependent variable is q. Actually, I shouldn't put q of t. It should just be q. So let's get rid of those brackets. Okay, and argument error because I need a del bar q. Let's run it again. Argument error again. Of q t comma q. What's wrong with that? Can it solve a simple one? So, oh, because I need to put in the equation, right? Do I need to put in q prime or something? There we go. So we have a C1 there. And we need to make sure that's, yeah. At t equals 0, we get 100. Because I'm pretty sure. Let's just make sure once again. Okay, so we'll just assume that there's 100 fish to start off with. Okay, so what I'm going to do is I'm going to solve this guy. I'm going to replace C1 with just C. equals 100. I'm going to solve for t such that t equals 0. So c is that number. So I'm going to define a new q function. So define a q of t now equals, use this guy, get rid of this thing over here, replace it with a c, and I'm just going to define c equals this thing. So now if I type in q, there's the new formula. So let's analyze it. So 6, and then I go to methods functions. I'm going to analyze. Analyze with the domain, why not? So we're going to put in q of t, comma 0 to infinity. No stationary points found. Maybe let's graph. Just because it can't find stationary points doesn't mean that there are no stationary points, because sometimes the cases can't do the solve command. So q of t, no. I want a q of x. Okay, let's change this back to 1,000. And we don't, that's funny. What if we extend this out to 100 or something? There's still an asymptote. Serious? It's 8.5. Well, I guess there's not going to be a stationary point, because, yeah, what if it's just an asymptote? I don't know. So what's the asymptote going to be? Is it still 1000? That point, asymptote looks like it's 950. I'm just going to say 950 because that's what the program's saying. And I don't know, hopefully that's right. Any other way to tell? So where's the function? Here's the function. Oh, here's the 950 over here. So as t gets bigger and bigger, these two exponential factors are going to cancel, and it's just going to give you 1. And this 8.5 is going to be negligible. So yeah, it makes sense you're going to get 950 instead of 1000. Okay. Question 5. And then we've got question 6. Right, 57 minutes. So we've got 20 marks left. So hopefully it's not too bad. So points, okay, find the vectors. This is looking like exam 1. So find the vectors a, b, a, c, and show that the area of the triangle ABC is 1.5 square units. Okay. Let's try to find AB. So AB is just OB minus OA. We might be able to define this on the CAS. Let's insert a new problem page, and I'm going to define A equals. We have 1, 1, 2. I'm going to define B equals 1, 2, 3, and I'm going to define C equals 3, 2, 4. So what's B minus A and what's C minus A? B minus A is 0, 1, 1. So we have J hat plus K hat. And then AC is C minus A, which is 2 I hat plus J hat plus 2 K hat. Okay. Show that the area of the triangle ABC is 1.5 square units. So the area of the rectangle spans by, AB and AC is just the norm of the cross product. So if you take a look at the triangle of AB and C, that's just going to be half the cross product, or the norm of the cross product. So area, or triangle area, that's just going to be 1/2 of the norm of AB cross AC. So let's compute the cross product. Cross product of B minus A and C minus A. And then we'll take the norm of this guy, and it's going to be 3, and then we divide by 2, and it's going to give us 1.5. That's going to be 1/2. And then I'm just going to put 3 here, and that's 3 on 2. Okay, find the shortest distance from point B to line segment AC. So line segment AC, let's see. So here's A, here's C. The line segment AC can be described by the direction vector C minus A. Okay, so let's use the program for this. So the shortest distance between point and line segments. So we're going to go to mspec line plane. We're going to go to line and points. So what's the line? It's you give it a point, so it's going to be A. You give it a direction, which is C minus A. And then you give it the points that you're interested in, which is B. Distance is 1. And let's do a bit of working out as well. So the line, here's the line equation that we're working with. So the vector from the line, we've got the projection, the perpendicular vector, and so on. So here's the line. So the equation is going to be, the equation of the line is going to be, let's see, we have, yeah. Do I want to do that? I'll just write it down. So 2 lambda, and then plus 1. And then I'll do lambda plus 1. And then I'll do 2 lambda plus 2. So that's the equation of the line. And then to find the shortest distance, what you need to do is, you know, it passes through A. Okay. And then what you need to do is you need to find the, almost at the perpendicular distance. So you take B, you project BA, or you project AB, I think, onto the line AC. And that projection gives you, this projection onto the line here. And then you calculate the perpendicular, perpendicular vector, and that should be it. So projection is, you have 2/3, and then 1/3, and 2/3. So the perpendicular vector is just going to be, negative 2/3, and then 2/3, and 1. And if you just calculate the norm of that vector, that should give you 1. All right. A second plane, psi, was there already a plane here? Points with, okay, so A, B, and C all lie in a plane pi. Okay, so there's a second plane psi here, which with this Cartesian equation, at what acute angle does the line given by this thing intersect with psi? Give your answers to the nearest degree. So let's use plane line. So we'll go to line plane. I want plane line. Plane line. So I'm going to type in the equation of the plane. So it's going to be 2x and then minus 2y minus z equals negative 18. And I'm going to type in the line. So a point that the line passes through looks like it's going to be 3, 2, 4. And then 1, negative 2, 2. 1, negative 2, 2. Is that the same line we had before? I think so. Maybe. I don't know. Let me just check if I got that right. So 3, 2, 4. And then 1, negative 2, 2. And then we have 2x minus 2y minus z equals negative 18. So acute angle is 26.38. Yeah. So the normal vector, you can do it this way. Normal vector is this going to be, 2, negative 2, negative 1. The intersection point, that's just going to be negative 1, 10, 4. So you can just literally copy down the working out. You don't need the parameter value, I think, but once you got the normal vector, you just use the dot product formula with this direction vector here, and then you get the angle. So angle, it's the cos inverse of those two vectors there, which I'm not going to write down the working out because I'm too lazy, but you should though. It's 26.38, 39 degrees, which I'm just going to round to the nearest degree as 26 degrees. This is the acute angle. A line L passes through the origin and is normal to the plane psi. The line L intersects psi at point D. Okay. Write down the equation of the line L in parametric form. So a line L passes through the origin and is normal to the plane psi. That means that that line must have, so the normal vector of psi is 2, negative 2, negative 1. So if you want to write it in parametric form, it's literally just r of t is equal to 2, negative 1 times t. And that passes through the origin when t equals 1. Find the shortest distance from the origin to the plane psi. So you could probably use this, but I'm just going to use the program for it. So I'm going to do, you can probably just use this again, but change that position vector to 0, 0, 0. And you get, what do you get? The shortest distance. No, I'm using the wrong program. I want points and plane. So I'm going to go to plane points, and then I'm going to type in that plane again. So 2x minus 2y, and then we have a minus z equals negative 18. Oops, equals negative 18. Okay, and then the point I'm interested in is 0, 0, 0, the origin. Distance is 6. How do you show the working out though? Well, you got the unit normal. The point D. What is the point D? Well, using the other program before, the point D, the intersection point was negative 9 on 2. 9, comma 9, negative 9. Okay, how do you get that? You basically just take this line here and you solve it simultaneously with this Cartesian equation. I think that's the way to do it. And then you got the points D here, and then you just calculate the norm of this, and it should give you 6. So you can check that. The norm of negative 9 on 2, comma 9, comma negative 9 is not negative 6. It's not 6. Plane points 2y, 2x, minus 2y, minus z is negative 18. Here's the origin, saying the distance is 6. Find the shortest distance from the origin to the plane psi. Let's see. So this program, what did I do? I put in the plane. This is plane line, so I put in plane. I put in a point the line passed through in the direction. Is that the right direction? The direction of this line is normal to the plane. So I put in the wrong direction, I think. This should have been, I think, because I used it from the part before, which is wrong. This is a completely different line. I think that's where I went wrong. So it's 2, negative 2, and then negative 1. Right, so there we go. That makes a bit more sense now, because before the angle was 26, which was wrong. Because this line over here, it should be normal. The acute angle is 90. So we have an intersection point. So this is the intersection point D that we get. So D is that point. Negative 4, 4 and 2. And yeah. If you just take the norm, that should be 6, right? So take this, apply the norm to it, should be 6. So therefore distance is 6. In terms of working out though, you just need to convert this. I forgot how to find the intersection point between a line and a plane. I'm pretty sure what you do is you just take this parametric form over here. So you write it as x equals 2t, y equals negative 2t, z equals negative t, and you plug all that into the equation of the plane, and you solve for the value of t, which does the job. And then you plug the value of t back into your line over here, and that gives you the point d. Right, and then you just calculate the norm of that point, which is 6. Find the coordinates of point d. We just did that. We just did that. Is that a 1 marker? Hopefully. It's 2 marks. What? Are we doing something wrong here? So we have a line passes through the origin normal. Write down an expression of the line parametric form. Find the shortest distance from the origin to plane psi. I'm just going to say it's negative 4, 4, 2. I don't know. Didn't we need that in our working out? to find the shortest distance? I don't know. There was probably some other way to find the shortest distance, which maybe I forgot, but yeah. I'll just take that as the answer. So the working out is from before, which I'm not going to write down because it can't be stuffed. Right, question 6, final question. Bit of type 2 error. That looks nice. So let's work through this. A forest ranger wishes to investigate the mass of adult koalas in a forest. A random sample of 20 such koalas. So you've got sample size, sample mean. It is known that the mass of adult male koalas in the forest is normally distributed with standard deviation 1 kilogram. Find 95% confidence interval for the population mean. Okay, so let's insert a new, on a new graphs page, a new problem page, and we'll go to the confidence program for stats, confidence. How does confidence work? I forgot. So it was, wait, how does it work? Confidence, you put the n, x bar sigma level. Okay, so what's n? N's 20. X bar is 11.39, sigma is 1, and level is 95. So literally just putting these numbers in the order that they appear, which is pretty cool. So 20, and then we have 11.39, and then we have 1, and then we have 95. There's our confidence interval. So we have, let's see, we have 10.95, correct to 2 decimal places, so 95, and then we have 11.83. 60 such random samples are taken, and the confidence intervals are estimated or calculated. In how many of these confidence interval would the actual mean mass of all adult male koalas in the forest be expected to lie? So we have, this is a confidence level of 95%. So your population mean is only expected to lie in the confidence interval 95% of the time. So 60 such random samples are taken. In how many of these confidence intervals would the actual mean mass of all adult male koalas? Yeah, it says 95% of 60, which is 0.95 times 60 is something, 57. Alright, the ranger wants to decrease the width of the 95% confidence interval by 60% to get a better estimate of the population mean. How many male adult koalas should be sampled to achieve this? So this is kind of like the methods question in exam 1. So if you know how to do that, you know how to do this one. Let's hopefully I know how to, I can't speak today for some reason. Hopefully I know how to do this question. So, I forgot how to do this question. So a ranger wants to decrease the width by 60% to get a better estimate of the population mean. So he wants, we want the new margin of error to be equal to, so the new margin of error to be equal to 0.4 of the original margin of error. That's a decrease by 60%, I think. No. So we want, if we want to, let's see, want to decrease the width by 60%. So margin of error divided by, I'm actually so cooked today. What on earth is going on with me? Let's see. Let's think about this. So if you decrease the width of the confidence interval by 60%, then yeah, the new margin of error should be 0.4 of the old margin of error. So let's write out the formula. It's something over n. It's something over the square root of n. That's something I don't care about. So let's try to put that 0.4 in somehow. So this is supposed to be, my whiteboard is not working again. So this is 0.4 times something over square root of n. And I want to put that 0.4 in. So this is something divided by square root of n divided by 0.4 squared, because it's in the square root. So what's n divided by 0.4 squared? N is 20. So I want 20 divided by 0.4 but squared. That's 125. So whiteboard again is not working. So n equals 125. I'm just going to go ahead and check that with the confidence program, just to make sure that I'm not getting anything mixed up. So 20 now becomes 125, and I get this. Let's calculate the difference over here. So this minus, actually I can just get the length. The length's already shown. So here's the new length, and what's the old length? The old length was something. Here's the old length. Now is this new length 40% of this old length? Let's see. So it's 0.4 times this guy, and it seems like it is. So looks like we got it. Okay, so it's 125. It is thought that the mean mass of adult male koalas in the forest is 12 kilograms. The ranger thinks that the true mean mass is less than this and decides to apply a one-tail statistical test. A random sample of 40 male adults is taken. Okay, so let's highlight. So it's thought that the mean mass, so this is the null hypothesis. One tail, a random sample, so this is sample size, and here's the sample mean. Write down the null hypothesis for the test, and we probably needed to perform this test on the next page. Let's see. 1% level of significance, assumes norm distributed 12 kilograms. Yep. Find the p-value and then draw conclusions. Okay, so we just got to, do the hypothesis program. So let's do that. So we're going to go to stats hypothesis. What's the null hypothesis mean? It is 12. Population standard deviation is it 1? Standard deviation of 1, okay. Sample size, what is the sample size? 40. Sample mean, 11.6. Significance level, it is 0.01. And one or two tail, well, it's going to be a one tail. So we get a p-value of, let's write down the hypotheses first of all. So the hypothesis is going to be, this thing over here. So we have H0. H0 is mu equals 12. And H1 is mu less than 12. Okay, so p-value. P-value is going to be, it is 0.005. How many decimal places? 4 decimal places. So 0.005. And then we have a 7. Draw conclusion. Since p hat is less than alpha, so you can literally just copy this down. Since p is less than, did I say p hat before? I meant the p-value. The p-value is less than 0.01. What we're going to do is reject H0, favor H1. Right. So we're going to reject H0, and we're going to favor H1. What does the critical sample mean? The small sample mean H0 not to be rejected in this test. So we're just gonna do inverse normal. Actually, that's something I should put into this program, putting the critical sample mean. But that shouldn't be too bad to do, because if you think about the normal distribution, it was 12, right? And we're doing a one-sided test, so it's going to be over here, and we want this thing over here to be equal to 0.01. So we're just going to do some kind of inverse normal. So let's do that. So probability, and then we'll go to distributions, inverse normal. the area, we want that to be 0.01. The mean is 12, and the standard deviation is 1 divided by the square root of 40. And that gives us 11.63. 3 decimal places is 632. Right, so as you can see, the sample mean we had before was 11.6. That was too large, so we didn't reject, sorry, 11.6. Yeah, this was slightly too small. So that means we reject H of 0 because it was too far to the left. But yeah, this is bigger, and it's just enough so that, you know, you don't reject. All right. Suppose that the true mean mass of adult koalas is 11.4 and the standard deviation is 1. Level of significance still the same. What's the probability of the ranger making a type 2 error in the statistical test? Let's use the type 2 error program. So we're going to go to stats, type 2 error, and then it's still 12. 1, sample size is 40, right? We'll assume it's 40. Sample mean, true mean mass is 11.4. So the sample mean is, we'll just take that to be 11.4 in this case. And then we'll do 0.01 once again. This is one tail test. And that's a type 2 error probability. 0.071. Because this is assuming that 11.4 is the true mean. Assuming that's the true mean, which is, yeah, that's how you make a type 2 error. The frequency curves for sampling distributions associated with H0, H1 are shown below. Label the critical sample mean on the diagram and shade the region that represents the type 2 error. So it was 11.6, wasn't it? 11.6 something, 632. So 11.632, so this is 11.5, 11.6, 7, 8, 9. So 632 is going to be right over here somewhere. So if we take a look at this part, that's the type 1 error. And everything to the right here, that's the type 2 error. What are we even doing? The frequency curves, labeled the critical sample mean on the diagram. So the critical sample mean is that 11.632, which is right over here. 11.632, and shade the region that represents the type 2 error. So that's assuming, type 2 error is assuming H... Oh, 1 second. So it should be over here, right? VCAA labeled this wrong. It should be in H0 and H1, right? Because this is 11.4. That should have been H1. Was that... I think that's a labeling mistake. Is it? I don't know. So yeah, that's the type 2 error region. Right over there. And with that, we are done. So hopefully I got most of the questions right. I don't know if I did or not, but yeah, that was a very easy exam. Very, very easy. So a lot of people, as I said before during the video, expecting a lot of raw 50s from this one, because I can see a lot of people getting yeah, full marks on this one, and also exam 1 as well. Yeah, so question 1 was just, what even was question 1? It wasn't even a question. Question 2 was a bit interesting though. Got nice roots of unity, as well as that last question, which I'm kind of not sure if that approach is valid or not. But I think that should be fine there. Question 3. Question 3 is a straight computation. Question 4 was nothing too special, I think. Maybe part E might have been a bit tricky, but I don't think it was that bad. And yeah, it was a sketching. And then question 5, the line plane one. I mean, nothing too special there. I'm just a bit unsure about the D, E, and F, and I can't be stuffed doing it properly because I'm tired. Question 6, just straightforward hypothesis testing stuff. So yeah, nothing too special with this exam, I think. I think it was pretty straightforward. I'll compare my solutions to other people's, and I'll comment below if there's any mistakes. And yeah, hopefully I get a decent mark on this. Hopefully at least a 70 over 80. We'll see though. Anyways, that's all for this video. Hopefully it helped. And yeah, thanks for watching.